welcome our friend Lisa the Hole. Hello, I'm Lisa. Oh, hi Lisa. So, how is going? Well, I'm okay, but I hear that today we're going to talk about the null pointer exceptions. And oh, I'm so scared. So scared about the null pointer exceptions. Don't worry. In 42, there is no null, so there is also no null pointer exceptions. What happens if an object is just not there? Well, if you think about collections, collections, lists, I know, I use them all the time, very nice. The lists have a finite size, right? Yeah. And so if you try to read outside of the size of the list, you get a dynamic error. But I just have to control on the size, right? What if you just have a list of 0 or 1 elements? That will just be like a variable that may or may not contain an object. That is exactly like normal variables in other languages that support nulls. Oh no! So, we don't have the convenience of nulls, but we can still express all the same problems. Marco, what are you doing? Yes, in 42 we don't have the concept of null at all. There is no way for local binding to not have its value. So every parameter, every field, every local variable will always have a value. Sure, you can have an empty list, but that's not a null element. That's just a particular kind of list that is empty. You can have an empty string, but that's not null. It's just a particular kind of string that is empty. Now, you will be surprised on how many programmers actually get confused between the difference of an empty list and a variable of type list that contains null. 42 avoids this confusion by simply removing the concept of null in the first place. So if you want something that can express information in any amount, including 0, you have to define a kind of data type that can discuss about emptiness. So a string can be empty, a number can be 0, a list can be empty, and so on. However, sometimes you really have a data type that is already there and it represents something specific, and you want to have like a companion data type that represents either nothing or an element of a certain type. And to do that, you can use the optional type. That's just a kind of collection that is like a box that contains either 0 or 1 elements. In 42, you can create your optionals by doing collection.optional of point in this example. And now we get an optional point. So we can define our immutable point and our mutable point, and then we can have our immutable variable point box and our mutable variable point box. Then we can have our assert x and checks p00 is in p00 box. This will return true. We can also extract the element from the box by doing .val. So p00 box.val will give us p00. We can also use .val to get a read reference on our mute box. We can also use an optional as the condition of an if, and in this way we will check if there is something inside of the box. So if there is something inside of the box p00 box, then we debug printing %p00 box, and this will give us in output oh no, I actually update the printout. I decided that it was better to have acute parenthesis so that it's not getting confused with the printout of an empty list. So here you will get printing acute parenthesis point round parenthesis x equals 0, y equals 0. If we have a mutable optional, we can use #val to extract the reference to the mutable object. and then we can mutate it. Here, for example, I'm setting the x-coordinate to 50. Of course, a mutable optional of a mutable object is a deeply mutable object, and thus we have to be careful with aliasing. In this case, if we print p01, we will get x equal 50. Then I'm showing that you can update your boxes with just empty optionals, and you can obtain them by just writing your optional type open close. If you really like named methods instead of operators, you can use .isPresent in order to check if the element is there in a more verbose but maybe more readable way, depending on what you prefer. I will expect some of you at this point to be confused about line 17, because we are updating our P00 box, but our P00 box is immutable, so how can we update it? Remember, updating a local binding, it's about the binding being var or not var. It has nothing to do with the reference being immutable or mutable. You can have a var number, that is, the local variable can be updated, but the number in itself is immutable. In the same way, you can have a non-var local binding that is mutable. That is, that binding is very solidly attached, but the object that is connected to that binding can mutate. So, for example, it can change its orientation. There are so many interesting programming patterns with optionals. You can use and or, the short circuits Boolean operations. That is, if I have my O1 and O2 string optionals, then I can do if O1 and O2, and the body of the if is going to be executed only if both optionals contain an element. However, we can also use and or to select one optional between many. So, for example, if I have O1 and O2, and I have a preference for O1, but I can use the content of O2 if O1 is empty, I can just write O3 equal O1 or O2. And here O3 is going to be equal to O1 if O1 has an element, otherwise it's going to be equal to O2. This trick is very useful with OR. It's a little bit more obscure with the AND, but maybe there are some useful cases for it. So you can write O4 equal O1 and O2. And this is going to select O2 if both O1 and O2 are present. Otherwise, it's just going to be the empty optional. So if you want to select the last optional of a list of optionals, but you only want to get something if they're all present, you can use the AND. On the other side, if you have a bunch of options and you want to select the first one that is not empty, you can put all of your options in OR. If you want to convert your optional in an actual Boolean, well, you can just write not. And yes, it looks a little bit hacky, but I think it's quite cute. The idea is that those optional types override the not operator. And so, not optional will be true if the optional is empty and false otherwise. Then we just invert our Boolean again with a not to get the information about our optional as a Boolean. It's pretty boring to always have to check if the element is present and then call val, otherwise maybe provide an alternative result. And so the optional type offers a method val or else that lets you specify an optional value that is going to be the result of your val or else. In this example, in line 14, we just return a constant string that is very fast to compute. It's just the constant, there. But sometimes we may have a very costly computation to compute this default value. And in a language like Java, we may use a lambda that will be called on demand if we really need to compute this default value. However, I will argue that the lambda is overkill in this situation, and just a simple OR will be enough. Indeed, in most languages, the bar OR operator is short-circuited. That is, we first execute the left side of the OR, and only if the left side is falsish, we go to execute the right side. That is, in line 17, we show that if we have this makeDefault.lotsOfTime method that can compute our default, but is quite expensive, we can just write O1, our optional that we hope contains our value already there, already ready, or if O1 doesn't contain the value, please compute s.opt of makeDefault that takes a lot of time. So we manually create a full optional that surely will contain our value. Then we can just extract the value by using val with a parenthesis, and boom, we have a sound way to always extract a value without the risk of getting a dynamic error. That is, as for line 14, this is a way to always get a value out of our O1 and to not get a dynamic error if O1 is empty. While listening to this video, you may have been worried mad about performance. You may have been there with your hands in the air saying, no, you are creating new objects to box those objects so that you can get your boxes with 0, 1 elements. So now you're basically putting yet another object on the heap, and that's gonna be slow. And no, relax. First, 42 builds on the JVM that is exceptionally fast at allocating objects. Second, optionals are optimized away most of the times. That is, in near every reasonable use case, you are just going to create your box in the 42 syntax. But in the actual execution on the machine, the system is just going to use directly the value instead of the box, or a null instead of the empty box. So you get the same performance of using nulls with the type safety of having optionals. As you may know, Java now also supports optionals. But Java also supports null, and for retrocompatibility, Java will never be free from nulls. So right now in Java you have both nulls and optionals. In particular, an optional is an object, and so it can be null. So you gain reasonably little in Java by using optionals instead of nulls. Since Java cannot possibly get rid of nulls, the addition of optional is controversial. Yes, if you write a self-contained chunk of code and you never use nulls, and your static variables are designed so that they are initialized in the right order so that you don't get a null randomly injected by the system, you will get a null-free environment. However, if you are using Java as a normal person, using the standard Java library, for example, or using other code wrote from other people, you are going to be in an environment where you have both optionals and nulls. And so, do you gain something? Maybe, but technically speaking, everything can still be null in any moment. Now, to rise a little bit the tone of the discussion and to go to a little bit of a more complicated setting, are not just used to represent optionality. So, that's maybe the most common use case, like there is a field and this field may or may not contain a person. And so you can have this field be of type optional person. However, there is another reason to use nulls. That is, you are trying to make some kind of circular initialization. And you want to have a first initialization phase where you have your nulls, and then directly after, before you expose your objects to the public, you will fix your circular links. That is, whenever the user actually see your objects, they will always see the actual value there. So it will be a little bit counterintuitive to have an optional field there, because you will be basically documenting to the user, hey, this object may or may not be there, but you actually want that object to always be there. So how can you sort this since we don't have null in 42? Well, there are two ways. One is to just use proper object-oriented patterns and have a private optional field and just expose a getter that looks a lot like the field, but is actually doing the .val internally, so that it's exposing the already unboxed optional. 42 also offers forward types that allows you to avoid optionals altogether when you are creating a circular initialization. But they are a little bit of an advanced feature, and so we're not going to see them in this tutorial. Okay, that's all for today. See you next time for maps and sets!